Hello everyone, I'm Zhou Fang from Huawei Global Training Center, Data Communication Department. Today I will introduce about VLAN configuration principle. This is our typical topology. This page describes the VLAN generation. There are two aggregation switch, connected 4-axis switch, and multiple PC connect to our network. From this topology, we can notice it is a broadcast domain because we use all the Ethernet switch connect to each other. The previous chapter we have learned a broadcast domain. It means all the network is based on layer 2. But the client have this requirement. For example, this user asks, I do not want to receive broadcast packet from C. From this topology, the A and C, even they connect to different access switch, but they all belong to the same broadcast domain. So we need to control this type of broadcast. So that's why we have the VLAN. Okay, the VLAN function. VLAN can divide this kind of PC. In this example, it divides the PC into two groups. The yellow PC is in group 1. The blue PC is in group 2. In one group, they can directly communicate each other. But in different group, they cannot directly communicate. And in the yellow group cannot receive any broadcast packets from the blue group. That's one function of the VLAN. How to implement the VLAN? We have this tag. We use tag to control the VLAN packet forwarding. In this topology, we have two switch and two hosts. Host A sends a packet from this switch and across this link to another switch. When the packet across one switch, if we have finished the VLAN configuration, it will carrying this frame will carrying the VLAN tag. This VLAN tag is a number. In this example, the VLAN number is 5. When this packet arrived at this switch, it will checking the VLAN tag information and compare with this interface. If they have the same VLAN ID, this frame can pass this interface. But in this topology, this interface only permit VLAN 1 to pass. So this packet cannot fall into B. This is use VLAN to control the traffic, and we use tag to realize. This page is the VLAN tag information. How to describe a tag? This is an original and tagged frame. If we implement the VLAN, we have this VLAN tag here. The switch will input the VLAN tag between the source MAC address and the type information. That means each frame will add 4-byte long tag. This tag information is 4-byte long. Because the frame information has been changed, so the FCS verification is also changed. So compare with the untagged frame and tagged frame. These two parts has been changed. Within one tag, this is 4-byte long. It can divide into multiple parts. The TPID, priority, this PRI is priority. It can use for quality of service. And the CFI and the VLAN ID. This part is most important because our tag information, our tag number is inside of this part. This is called VLAN ID. VLAN ID is about 12-bit long. So it's about 4,000 VLAN numbers. How to generate VLAN tag? This is another example. One PC and 4 hosts, the host A, B, C, and D. Our target, our planning is host B and host D can communicate with each other, which are in the same VLAN. And host A and host D, they are in the same VLAN. How to implement port 1 and port 7? They connect to host A and host C. We just put the same VLAN configuration on these two interfaces. That's finished. Another port 10 and port 2. This table describes the VLAN configuration. Port 2 and port 10, we input configure the PVID as 10. Port 1 and port 7, we configure as 5. So after all this configuration, the same group can communicate, different group cannot communicate. In this chapter, we have learned VLAN tag, which is 4-byte long, and 12-bit long VLAN ID. How to generate VLAN tag? We can configure the VLAN tag on the physical interface of the switch. Okay, this chapter, the question, what's the VLAN tag length? After we add a tag to a normal frame, it will add the length of 4 bytes. That's the length of the VLAN tag. That's all for this chapter. Thanks for watching.